Yeah, hello folks, this is Param. Yeah, in this video we will cover the simple concepts of what is Spark, how can you define Spark, and a little brief intro about Spark architecture and also why we use Spark on top of Hadoop. Uh, Also, what are the languages that we need to know in order to work with Spark, and do we need to install Spark in the local system, or can you use Spark in any of the online platforms, or what are the platforms that offer working of Spark. So yeah, we'll dive into that video. Before defining what is Spark, let's see how Spark is defined from its own contributors. Yeah, well, we know that Spark was developed by Apache. Uh, Spark is a multi-language engine for executing data engineering, data science, machine learning on a single node mission or clusters. Well, I will explain you that in detail. So let's also see how Spark was defined by AWS, one of the cloud platform. Spark is an open source, meaning that the source code is available for everyone, and a distributed processing system, meaning that its architecture is built on using distributed processing and is used for big data workloads. It utilizes in-memory caching. It's a big term, a very good concept in Spark and the Spark, but you need to know if you are learning about, but and more specifically if you are ever sitting for a interview, then you should be knowing that what is in memory caching. And it provides development APIs for Java, Scala, Python, and R, and supports reuse across multiple workloads: batch processing, interactive queries, real-time analytics, machine learning, and also graph processing. Well, don't worry about those technical terms. I will be explaining you in detail of those things. Yeah, well, if I ever asked a question of what is Spark and how can I define Spark, I will use a simple words, a few simple words and explain that in simple way. Let's see how I define Spark. Let's see. What is Spark? How can I define Spark is it is a general purpose in memory compute engine. It is an open source that was built by Apache using Scala for computing large-scale data that could be batch processing or stream processing and things like that. See, well, I'll break down this definition in detail, but before that, I wanted you to know about Hadoop, Hadoop architecture, and also Hadoop ecosystem. So the only reason, the main reason behind me introducing Hadoop ecosystem, Hadoop architecture is to understand it, is to have a better understand about Spark, why Spark is built, and what is in-memory caching. So let's see what is Hadoop. Hadoop is a framework that allows distributed processing. I suppose that you are aware of what is distributed processing if you are uh, aiming to know about Spark or Hadoop. Distributed processing, large system, a processing of large data sets across clusters of computers using simple programming modules. It is designed to scale up from a single server to thousands of machines, meaning that you can use Hadoop for a simple source for a data of few MBs to terabytes, data of terabytes, petabytes also, using multiple clusters, multiple nodes, using cloud services. And yeah, well, we'll see a little bit about Hadoop architecture. The architecture of Hadoop has three major components. One is HDFS, abbreviated as Hadoop Distributed File System, which is responsible for storing data in Hadoop, and YARN, which is responsible for resource managers management in Hadoop, and also MapReduce, which is responsible for computing or processing the data that is stored in Hadoop. Well, and let's see what Hadoop ecosystem comprises of. Hadoop ecosystem is comprised of Hadoop, Hadoop architecture, and the tools that are required for working with Hadoop. See, there are several tools that serve around the Hadoop ecosystem, uh, but the main concept of me talking about Hadoop ecosystem is I wanted to you know that there are tools that we need to know in order to work with Hadoop. So a few of the tools were Hive, which is used for querying structured data, and HBase for again for storing, and Pig, which is used for querying unstructured or semi-structured data, and Uzi for scheduling. Well, we need to know all these tools in order to work with Hadoop. It's not a big question why we need, because these tools have their own working and their own syntaxes, and it takes much more time in order to learn each of the tools. Well, from this understanding, let us see how I define Spark in detail. As I said, it's a compute engine, meaning that it has the similar or the same responsibility of MapReduce in Hadoop architecture, that it is used for computing or processing, and it is a general purpose. So what do I mean by general purpose? Spark has the capability that it can replace most of the tools that surrounds the Hadoop ecosystem, meaning that we can use Spark for querying structured data, querying unstructured data or semi-structured data, and much more things for scheduling itself. We can use Spark. How can we use Spark? For that, we will be covering that in the next lectures. Let's see. What is in memory? What do I mean by in memory? For that, we need to understand how a query is executed in MapReduce using Hadoop. Yeah, let's say that there is a simple query or a single query that has to be executed by MapReduce in a Hadoop system. How MapReduce executes a single query is it will basically divides the single query into several jobs. Let's say job 1, job 2, job 3, and job 4 for time instance. And for each job, there will be an input, which could be input operation, which could be treated as write read operation. In order to make it more simpler, read or operation could be reading data from a hardware or HDF file system or any storage system, and after reading, job 1 will be executed. It could be any simpler function, executing simple function, and that there will be an output that will be again write to the disk, in the sense drive or HDF files, any storage that is available. And then again, and again there will be a read operation for the second job, and again job 2 will be executed, and then again there it will be again written down to the disk, and in such a way that entire every job has will be executed, and then finally there will be a output, right output for the desired query. So summarizing the entire working of MapReduce execution of single query, it has many read and write operations which could increase the burden on resources, increase the computational time, and also cost related to it. So this is how a single query is executed in MapReduce. When it comes to Spark, a similar query executed in some different format, in more sense using in-memory computation, meaning again a job several jobs will be allocated, in the sense that has to be executed in order to execute entire single query. So for that, there will be a read operation, input operation. This could be reading data from the uh, storage system, and job 1 will be executed, but the output from the job will be stored in memory, in the sense, in more sense, in RAM. And from that RAM, the input to job 2 will be given, and then job 2 will be executed, and then again the output from the job 2 will be stored in RAM, in memory, and again job 3 will be executed in such a way that there will be only single write operation at the end of whole query. So in summarizing how Spark executes, there will be a single read query and single write query, which decreases the number of times a data has to be loaded into the each job, and which decreases internally which decreases the computational burden on the resources, which is time efficient, cost efficient as well. So this is what in-memory computation in Spark refers to. From that we can say that what we can understand what in-memory computation in case of Spark. So from that we can say that Spark has the capability to replace MapReduce in the Hadoop architecture, and that is how we say Spark is executed on top of Hadoop. In more sense, unlike Hadoop, Spark doesn't has its own storage and its own resource manager. Spark is like, give me some storage system and resource manager that I can compute or process the queries much more faster. In literal sense, 10 times faster than MapReduce. So this is how we can say, from this base we can say that Spark doesn't entirely replaces Hadoop. It just replaces the working of MapReduce itself. So Spark works on top of Hadoop. And again, there could be questions like, how can we execute Spark sessions, like Spark queries? What are the languages that we need to know? So in order to answer that question, it is very simple. We can use it's a general purpose, and we can use multiple languages in order to execute Spark sessions, Spark queries. So those will be a Python, Scala, Java, and R. It is entirely depend on user. So we can execute Spark queries in any of the languages, but if you are a beginner and doesn't know any of these languages and you are starting right just now, then I highly appreciate and recommend you to start with Python. Python has many more libraries, not just useful for just Spark itself. It will be useful for ML, data science, and there are much more uh, advantages with Spark. Easy to learn, easy to scale, and easy to understand itself. Yes, and again there will be questions like, where can we execute these queries using these languages? Well, you can use local environment, in the sense local system. You can download Spark environment, install Spark, and configure in environmental variables, configure the installations, and you can use that in the local system. As and also you can use Spark in let's say online platforms. See, you can use that in local computer and also on online itself. Well, see, I would highly encourage you to go with online. It is because we need to understand that whatever we do, or whatever the tools that we learn that are around data engineering, we should understand that we are going to use them on a cloud server. So bringing your local laptop, local system everywhere you go and anywhere you go, it would be quite impossible for several reasons. And yes, similar to Colab and Jupyter notebooks, where we can write Python program, there are several platforms where we can write Spark sessions. Databricks and Azure are two major such platforms where we can write the Spark sessions, and they provide notebooks, workspace notebooks for executing Spark queries sessions, and that is for this lecture. Let's see what all the topics that we have covered in this lecture. See, we have seen how Spark is defined, and we have defined using our own words with some technical terms, and I have introduced to Hadoop ecosystem, Hadoop architecture, and defined our Spark definition in detail using those concepts as well, and seen how Spark replaces MapReduce, how why it is 10 times faster than MapReduce, how it won't replaces entire Hadoop but replaces only MapReduce, which is a computation component of Hadoop, and uh, and also why we use Spark on top of Hadoop rather than just completely replacing Hadoop, and also seen what are the languages that we can use in order to work with Spark, and where can you implement Spark with the we can implement both in local computer, local environment, or using online. So that is for today.